Thanks very much, Tad, and thanks to everybody for inviting me here. I was asked to come here a few weeks ago by Martin Heavyhead, and because of, if you look, you probably noticed in the news, there's been a lot of pretty bad hurricanes and wildfires and droughts and heat waves recently, and of course it's making people think, how much has this got to do with global warming? And again, I'm not a climate scientist, I'm a philosopher, but my job, what I sort of do is I synthesize, I try and put it all together from many different perspectives. We have a lot of really, really good earth and environmental scientists at U of L, and I learned from them and from the literature and other scientists I know, and do my best to try and distill it down into something that I hope is useful. So again, let me just launch in. The image here is Hurricane Irma, I believe. That was one of the ones that Category 5 storms that caused a lot of problems this summer. Basic plan of work in my talk. Quick version, what's happening right now. Some of it's pretty bad news. How bad could it get? So I'm sorry, there is some doom and gloom in this talk. Some of you have heard me talk before, and it always seems to start off with doom and gloom. But there are some rays of hope, I hope, and then some implications for Alberta. So getting back to the question of, okay, is Hurricane Irma, etc., is this made worse by global warming? Short answer is it's really complicated. If you read what the scientists say on this, they're very clear. It does not make sense to say that any particular event, such as a certain hurricane or the Cano fire, was caused purely by global warming. But what you can say is that, and they're saying this with increasing confidence, the frequency and intensity of weather-related events, such as wildfires, droughts, storms, etc., is very likely to increase because of global warming. And there's actually a lot of literature now on what's called climate change attribution, in which what they're trying to do is they do modeling, and you sort of do with and without modeling. So you try to impose global warming on the background of natural variation, because there is always natural variation, of course, and see how much difference it makes. And the answer is, yeah, it's making a difference. There's a recent estimate that there was a very bad heat wave in southern Europe this summer that was actually called the Lucifer heat wave, with temperatures in places like Italy and Croatia going up into the mid-40s, and that's estimated to be 10 times more likely because of global warming. Now, it's all an estimate, it's all probabilistic, right? But the basic physics, again, climate's really complicated, but the basic physics that's going on here is really simple. If you put extra heat into the atmosphere and oceans, all that heat has to go somewhere. That's not hard to understand. And it will go somewhere even if we have our cities, our farms, etc. in the way. It doesn't care. It just, heat wants to dissipate, and a hurricane is a heck of an efficient way to dissipate a few billion megatons of heat. So how bad could it get? So this is the doom and gloom part. Most people don't realize how bad it could get. Well, there's things called tipping points. So what is a tipping point? A tipping point is an effective climate change that would accelerate in a non-linear way. It would take off sort of exponentially or quasi-exponentially. And there's several possible tipping points that climate scientists are worried about. The one that I've done a lot of reading about recently is the collapse of, possible collapse of grounded marine ice sheets, such as WAIS means, WAIS is West Antarctic Ice Sheet. Scientists are freaking about this, and I've had conversations with top glaciologists, the American Geophysical Union. They're freaking about what could happen to the West Antarctic Ice Sheet. I'll come back to the details of that in a second. There could be major shifts in weather patterns, and the point being, you could get things sort of suddenly changing. Like all of a sudden the monsoon disappears, or all of a sudden you have a 2-year drought in some part of the world. One of the real wild cards here is possible acceleration of the emissions of methane from permafrost and marine hydrates in the north, which could greatly accelerate global warming because methane is a powerful greenhouse gas itself. And then species extinctions, maybe even including those talking primates themselves. We'll talk about that. So here's a recent, very conservative prediction. There's a paper that was published just a few weeks ago by Ramanathan and Xu. Now, Ramanathan is a very senior climate scientist at the Scripps Institute. I had the privilege of meeting him once. I can't say I know him well personally, but I did meet him. He's been around, sort of senior figure in climate science for years. And my impression of Dr. Ramanathan, which is sort of hard to quantify, is he's an extremely conservative person. He's not a wild-eyed, eco-freak or anything. He's very conservative, thoughtful, and he won't say anything unless he's checked it to 10 decimal places. And he and his colleagues have done a whole lot of math, and they argue that unchecked emissions lead to a 5% chance of catastrophic or existential outcomes by 2050. Now, only 5%. What's to worry? But Ramanathan says, when we say 5% probability high impact event, people may dismiss it as small, but it's equivalent to 1 in 20 chance. The plane you're about to board will crash. Would you get on a plane if there was a 1 in 20% chance that it wasn't going to make it down safely? You probably wouldn't, but we're willing to send our children and grandchildren on that plane. So let me get back to talking specifically about ice. So ice sheet collapse is one of the major issues of so-called tipping points. Okay, and a lot of people, actually, I didn't even know this until 3 or 4 years ago, and some scientists I was talking to told me I should educate myself in it. What many people don't know is that quite a lot of the ice in Antarctica and Greenland is in the form of what's called a grounded marine ice sheet. Now, what this means is it's a gigantic abyssal trench in the ocean floor. The trench in West Antarctica goes down to about 2.5 kilometers below sea level, and it's packed solid with ice, up to about 1 kilometer above sea level. And what's holding all that ice in place is its sheer weight. It's called ice over flotation. There's too much ice there for it to float. And if that ice should melt or collapse, it will raise the water level because it's over flotation. If floating ice melts, yeah, it doesn't raise the water level. It can cause some other problems, but it doesn't raise the water level. But ice over flotation will raise the water level. So the central basin in West Antarctica is roughly the size of Mexico. They've done the math. If it all collapses or melts, all by itself, it's good for 3.3 meters of sea level rise. There's also another large glacier in West Antarctica. There's a big one in Greenland called the Zachariah Glacier that's good for about 0.5 meter. Again, it has the same physical structure. It's a grounded marine ice sheet. And then there's some really big ones in East Antarctica as well, which have greater ice over flotation. Therefore, they're more stable because the weight of the ice holds them down, but also greater potential for sea level rise. If all the ice in the world melts, Greenland, Antarctica, everything melts, we're looking at 65, 70 meters of sea level rise. That's not going to happen anytime soon, but there's a realistic possibility that some of that ice could melt rather quickly. So paleoclimate is the study of ancient climates. It's very interesting and sometimes a very scary and depressing topic because, you know, what can happen before could happen again. They know that during the last glacial meltdown, 14,000 years ago, the great ice sheets in the northern hemisphere collapsed with incredible speed. And there was a thing called meltwater pulse 1A about 14,000 years ago where sea level rose 4 to 5 meters per century. 4 to 5 meters per century. We know that's how fast sea level can rise if major ice sheets collapse. Now, could that happen today? Well, we don't know. Okay. The other thing from paleoclimate, if you go back millions and millions of years, there's a rough correlation between sea level and carbon dioxide concentration. Right now we're hovering around 410 parts per million. A lot more than it used to be. Well, when I started teaching this stuff, it was about 385. Okay, we're at 410 now. At that CO2 level, according to paleoclimate, we're dialed into 15 to 25 meters of sea level rise. Now, of course, maybe paleoclimate doesn't apply in this case for some mysterious reason. Maybe Mr. Trump's going to write an executive order and overwrite the laws of physics. We're hoping, right? But right now, that's what it looks like. So the only question is timing. And you talk to glaciologists and read their work, and what they can tell you is there's a certain risk of these things happening. What they can't tell you is the timing. The only thing that, and the only other thing they'll tell you is that the ice sheets in Greenland and Antarctica are melting and breaking down much faster than anybody had predicted. So one glaciologist told me that in the 90s, when he was a student, he was taught, oh, it's going to take thousands of years for Greenland to melt. And now here we are 20 to 25 years later, and they're seeing it just crumble before their eyes, right? So ice can be stable for tens of thousands of years and then melt extremely quickly if it gets hot enough. So timing is a huge question here. Here's just a quick picture of, which I, of course, obviously stole from the internet somewhere, of the basic dynamics. So the Pine Island Glacier is one of the major glaciers in the West Antarctica. And what this shows, oh, I can go these little laser pointers here. I forgot that. Oops, crap. Okay. What this shows is that warm seawater goes down underneath the ice. So it can be 50 below up here, and you think, what could possibly go wrong? Well, it's +4 down here, and this is eating away at the ice sheet. And this is the basic dynamic, that this thing here called the ground, right there you have, that's called the grounding line. That's where the ice sits on the seafloor. Those grounding lines are going back by kilometers right now, by kilometers, to the point where you get into this interior basin where it goes, there's a rapid downslope, and there's about 6 different mechanisms that take over at that point that allow the ice to collapse very, very, very rapidly. And I mean, worst case scenario, conceivably within months or a few years. They don't know for sure. All they know is the potential for this to happen is there. Okay, so we're still in doom and gloom. So just to make it worse, here's another issue that again is really just emerging out of research, and again it's a relatively new issue for most people. It's and how to describe this. Right now, CO2 levels, as I say, are around 410 parts per million. What that implies is that even if we just miraculously stop all our emissions, like tomorrow morning, we're still in trouble, because at that level of CO2, we are already dialed in for very significant changes, possibly collapse of major ice sheets. Right? So scientists are beginning to realize that we have to have what are called negative emissions. In other words, there has to be something that will somehow suck a heck of a lot of CO2 out of the atmosphere, enough to reduce CO2 levels to something pretty close to pre-industrial concentration. And you have to be able to do that before those big ice sheets let go. We just don't know if that's technically possible. The technology for doing this does not yet exist. Now you can say, oh, what about planting trees? Well, yeah, we should be planting trees. There's a project in Pakistan right now to plant 1 billion trees. That's wonderful. But people have done the math again. You can't plant enough trees to do this quickly enough. It's just, there isn't room for enough trees on the globe for that to happen. So there's a gamble. Everything we're doing, all of our climate and energy policy, here in Canada, in Alberta, everywhere in the world, is all framed in terms of a gamble. It's an awareness that we are gambling with the ice sheets, and also to some extent methane release in the Arctic, because they don't know how quickly that could happen either. The gamble is we can maintain business as usual a little bit longer until we develop alternatives at a comfortable pace that won't upset too many people's investments. But we have all our chips in. We are all in on this. And this is the thing that people don't realize. There's a view that this is somehow discretionary. It's a lifestyle choice. Let's reduce our carbon emissions and recycle our beer cans, right? But it's much more serious than that, right? So, how's my time here? So here's my little glimmer of hope. Now, this is coming at it from a very, very different angle. I'm going to show you something that has only indirectly related to climate. One of the things that fascinates me is human creativity, innovation, ingenuity, the capacity of human beings to invent new things. And the comparison I can make is that when we come up with something new, it's sort of like in a video game. You know, if you win a certain level in a video game, you get more weapons, you get more lives, or whatever they call it in the game, and you can go on. And sometimes you can do things that you couldn't do before. And there's a sense in which that's what technology or innovation does. So as I should choose my words carefully, it doesn't necessarily have to be technological innovation. It could be innovation in terms of more effective social structures, better language. There's all kinds of ways in which we could innovate. And you sort of think about the technological innovations because they're the most obvious. Now here's a really interesting example from paleoanthropology. So what you're looking at here This is from a very fascinating book by Brian Fagan, who's a paleoanthropologist, a book called Cro-Magnon. So the Cro-Magnons were the early humans in glacial Europe, 20, 30, 40,000 years ago. They were modern humans. They displaced the Neanderthals, probably had them for lunch, I'm not sure, but we don't know for sure. And they had this huge wave of innovation. And so Fagan says, look, so what you're looking at here, the items at the top are called burins, and what that basically is a utility knife made out of stone. And this was their X-Acto knife, their utility knife of 30,000 BC, and they made other things with the burins. And one of the things they made sewing needles. And so they had rather good sewing needles made out of bone, either antlers or leg bones of the game animals. And Fagan says the humble needle ranks alongside the taming of fire as one of early humanity's most significant innovations. And you might think, hey, he's got to be joking. But the point is, remember this, they were living in subarctic conditions at the time. With sewing needle plus some burins, you can make tailored clothing. And you can survive, therefore, in cold conditions much more efficiently. So it's a survival advantage. But the thing that fascinates me, I mean, now the Cro-Magnon invented these. I'm sure other early humans invented in different parts of the world at roughly the same time. But before a certain time, there were no sewing needles. Humans or hominins of some sort go back hundreds of thousands of years. They didn't have sewing needles. At a certain point, we had sewing needles. It's a new thing. And you know, people say there's nothing new under the sun. I don't think that's strictly correct. So philosophically, it's very fascinating. But sometimes it doesn't work. So my son, Evan, and I were on Easter Island three years ago. Actually, I gave a talk here about it. Some of you might have heard the talk. This is a picture I took 3 years ago of some of the great moai, the statues on Easter Island. And what can happen, and Easter Island's an unfortunate example of that, is because it's very, very isolated and they had very limited resources, things can go wrong and a culture can reach a point where it's simply out of time. It's endgame, like in chess, where at a certain point you just don't have enough pieces left to keep on playing. You have to just resign. You can't win, right? And of course I could be wrong, but my impression of the story what happened on Easter Island is at a certain point, for various reasons, they were just out of options. They couldn't, and it's very, very easy to say, oh, that we wouldn't make the same mistakes they made, but that's not so easy to say that. Now, I haven't got time to get into the whole Easter Island story right now, but the point is they were us. You know, in many ways, we're just on a larger scale, we're arguably making similar mistakes. So we don't want to get into that situation where we're just out of options. So it's not even the collapsing ice sheets that worry me as much as the idea that we could get so ecologically stressed, so economically stressed that we can't afford, where we say we can't afford to do research and innovation, we can't afford to support education of young people anymore because, oh, it's too expensive, things are too desperate. Then we're really in trouble. So, that was my time. So what does this mean for Alberta? Okay, well, I have a lot of respect for Premier Notley. I think she's doing an extremely difficult job, and she's doing it very, very well. But she said last year, today I was asked about the future of the oil sands. How long into the future will the world need oil? Here's what I'd like to say. Oil and gas will help power the global economy for generations to come. And with great respect to her, I think she's dead wrong about this. Now, there's an old saying, prediction is hard, especially when it's about the future. So maybe everything I'm going to tell you is nonsense, but the trend that I see and that many other people see is that, for reasons I'm going to try and explain, time is going to come much sooner than most people think when oil and gas will be largely obsolete. But of course, this is a political issue too. I mean, Ms. Notley and her colleagues are walking a political tightrope. And I understand that. But it's as if our governments, both of our governments, both federally and provincially, are saying they want to have it both ways. They're somehow saying Canada can lead in the fight against climate change, but oh, by the way, we can somehow still have a vigorous fossil fuel industry for decades to come. And obviously it reminds me of that famous statement by Prime Minister Mackenzie King during World War II. During World War II, there was an issue called the conscription crisis, and Mackenzie King famously said, "We'll have conscription if necessary, but not necessarily conscription." Right? And I remember my dad, who of course lived through those days, telling me just how completely stunned everybody was by the incredible effrontery that he would have the brass to make that statement and somehow get away with it too. So it's sort of like today we're saying we're going to reduce fossil fuels if necessary, but we're not going to necessarily reduce fossil fuels, right? And that's a really hard trick to do. How are you going to do that? So it's a political statement, exactly. So maybe it'd be better politics in the run to simply tell the truth. Although I'm merely a philosophy prof, so I can say naive things like that, right? They pay me to be naive. Well, actually, there's an interesting comparison that academics like myself, to some extent, we're a bit like the court jester in the Shakespeare play King Lear. So the fool who is allowed to say truths that nobody else can say because you're allowed to not take him seriously. So we're so we're a little bit like that. Okay, so consider me the court jester if you want. But there's a big message from Mother Nature here, which is very real. We humans live in a vast physical universe with rules that we only partially understand, all right? And the universe, the laws of physics, do not schedule events in accordance with what would be politically or economically convenient for the province of Alberta, Canada. Right? And it's not just a political issue. So the Premier and her colleagues have to be very closely concerned balancing the political scales. I get that. But it's not just politics. There's something called the laws of physics going on here, right? If it gets warm, ice melts, okay? If it gets warm, storms become more powerful. The maximum velocity of a hurricane goes up when it has more heat to work with, right? That's not something you can't cut a deal with a Category 5 hurricane, right? There's no such thing, okay? So some inconvenient truths, and this is getting back to Alberta. So I say we've gone from crude to crud in Alberta. So why are we mining bitumen and doing so much fracking now? Because that's basically pretty well all we have left. Most of you will know that 30 years ago, the idea of spending billions of dollars in the tar sands would have been pretty well laughed at, because why would you, right? So most of the best quality oil has already been sucked out of the ground, and most of the money from it has been sucked out of Alberta. And that's another discussion which we can get into perhaps in the question period. So fact, okay, inconvenient fact, the oil that you produce from bitumen is one of the most expensive types of oil there is to produce. And as oil moves toward obsolescence, as more and more people are driving electric vehicles, for example, tar sands oil will become one of the first to become uneconomical to produce. Now, I'm not going to stand here and try and predict the price of oil 5 years from now. It's going to fluctuate up and down. But the trend has got to be down. It's just got to be. And then add to this the climate issues. Now, again, we don't know how fast these things are going to occur. If there's a crisis such as the collapse of West Antarctica, there's going to be increasing international pressure to cut fossil fuel use, right? And that could accelerate things. But one way or the other, even if the climate gives us a bit of a break, right? It's eventually going to be so much cheaper to use non-fossil sources of energy that oil won't be able to compete. Now, my colleague Jim Byrne has a friend who drove a Tesla S up from Long Beach, California, and it was back in 2013, and he estimated the Long Beach to Lethbridge is a pretty good drive. He estimated the energy costs he used. So, if a Tesla will show you how many kilowatt hours you're using, and it's the going rate at the time, I think it was something like, say, 8 or 8.5 cents a kilowatt hour. He spent $65 on the energy to drive from Long Beach to Lethbridge. Right? So what would the gas cost you, even in a very, very fuel-efficient car, for the same drive? $200 or $300? I don't know. Right? Now, a Tesla is an expensive car, but soon there will be cheaper EVs on the road. So I jokingly say soon even Senator Inhofe will be driving a Tesla. Right? So, in case you don't know, Senator Inhofe from Colorado is one of the most ardent climate science deniers. That it's all a liberal hoax. That okay. So, disruptive technology, that's the phrase people use. There are many, many people around the world who are working on technologies that will displace oil and eventually displace natural gas. And there's all kinds of these technologies that are in the works right now. In Dubai, of course, they have lots of sunshine in Dubai. There very recently is a solar power contract let at under 3 cents per kilowatt hour, right? The price of wind and the price of solar technology has been falling exponentially. So it's similar to Moore's law in computing, where there's an exponential increase in the computing power of chips, which is still more or less going on, right? And right now, some of these renewable technologies are following an exponential themselves in terms of cost and efficiency and availability. There's all kinds of biofuel, diesel jet fuel, biojet fuel in the works. And interestingly, some artificial photosynthesis. This is the one that really fascinates me. Now, it's not ready yet. I don't know how soon it's going to be ready, except I'm willing to say better sooner than you think. But just imagine the following scenario. You have on a farm, a large farm, you have 2 or 3 windmills generating electricity. The power goes into some apparatus, and at the other end of the apparatus is dripping diesel fuel into a big tank. Because you can actually synthesize hydrocarbons directly from CO2 and water vapor as long as you have a source of electricity. Now, it's not economical yet. It's just a science project, but there's some really interesting breakthroughs that people are making. And the point is, people are not going to wait for us. Okay, they're going to go ahead and develop these things. They're not going to wait until the investments in Fort Mac are amortized. They're just going to go ahead and develop these things. Okay, so I think it's inevitable that a large part of what's up in the so-called tar sands or oil sands will be stranded assets. I mean, for some time to come, there will be a use for the oil products as chemical feedstock for plastic manufacture. Things like jet fuel. Jet fuel is going to be probably the last thing to go, because we're a long way from having battery technology or anything like that could power a large airliner. People are working on battery-powered aircraft now. There are test models out just for short hop, not too big. They're working on it. It's very, very feasible. Our greatest asset in Alberta is not oil, etc. It's human capital. The creative ingenuity will find the sewing needles that we need. And you tell me, whatever we're investing now in research, education, development of new technology, it's not enough. Whatever the number is, and I don't know what the number is, it's not enough. The way I sort of picture this, if you think of the carbon tax, think of the carbon tax as a push. So carbon tax pushes you away from using oil, but you also need a pull. You need push and pull. So the way to have a pull is to make other alternatives cheaper, more widely available. And then it may very well be it's not the cost of the fossil fuels as such that matters, but the difference in cost between them and the alternatives. So what we need to do in Alberta, fine, you have a carbon tax, that is a useful tool, but you've also got to do everything you can to make the alternatives cheaper. So electric vehicles, batteries. Why don't we build a battery mega factory in Alberta? Somebody could be doing that now. All it would take would be a couple of $1 billion, and they could be competing with Tesla. Well, I don't have to. I've got a few loonies in my pocket here, but it's not going to quite do it personally. But the point is, people are doing this. And if we don't do it, somebody else will. It's just going to happen. So people sometimes say we have to think globally and act locally. Okay, so recycle your beer cans. Yeah, that's a good thing to do. But I also say we have to think globally and act globally. Right? I believe Alberta can be a global leader in the movement out of the fossil fuel era. The world is watching us. They are, because because we have gone so far on oil and gas. Now we say we're going to get away from it. So everybody's watching us to see whether we can pull it off, right? And so we've got to do a good job. Or we can wait for somebody else to do it for us and then pick up the pieces afterward. It's sort of our call. Okay.